Good morning to all. Hello, sir.
Yes, sir. Yes, sir. Good morning.
Audible.
Yes, sir. You're audible, sir. Yes, sir. You're audible,
Okay.
sir. Yeah.
Okay. So I request sir to give an introduction about the speaker. Sir, please proceed.
Thank you, sir. Personally, I welcome all on behalf of Rajarashwari College of Engineering. Is conducting under the Department of Mechanical Engineering, conducting 5 days ACT training and learning ATAL online faculty development program on lean manufacturing in Industry 4.0 scenario. So welcome you all the participants and the speaker for the day 2, session 1. So I introduce the speaker of the session, Dr. S. Vinod. He is an associate professor in production engineering department of National Institute of Technology, Tiruchirappalli, Tamil Nadu. He has completed his PhD from PSC College of Technology, Coimbatore. He completed his master's degree in production engineering from PSC College of Technology, Coimbatore, and bachelor degree in mechanical engineering from Government College of Technology, Coimbatore. He has a top ranker in his undergraduate and postgraduate studies. He has been awarded National Doctoral Fellowship for pursuing research by AICT in New Delhi. He has been awarded Highly Commended Paper Award and Outstanding Paper Award by Emerald Publishers, UK for the year 2009 and as well as for the year 2011. He is a recipient of Institution of Engineers Young Engineers Award for the year 2013-14. He has published over 150 papers in international journals. He is on the editorial review board of various international journals in the specializations of manufacturing and industrial engineering. His research interests include lean production and sustainable manufacturing, agile manufacturing, rapid manufacturing, product development, and industry 4.0. Welcome you, sir.
Yeah, thank you,
Over to
sir.
sir.
Yeah, thank you, sir. Dear organizers and participants, good morning all. The topic of my session is lean tools implementation. So in this session, we'll be discussing about the concepts of lean manufacturing, and we'll have the comparative aspects with the mass production system. Then we'll discuss about the elements of lean manufacturing. Then we'll proceed with the fundamental tools of lean manufacturing like 5S, TPM, value stream mapping, and further we will go ahead with the advanced secondary tools for lean implementation. We have a set of secondary tools. Then I'll try to show concurrently some case studies we did with the industries, so it will try to provide you the practical perspectives. Okay. So let me proceed. Sir, is my content and my voice clear? Okay. Is the content properly visible and my voice is clear? Sir, is my voice clear? Organizers? Am I audible completely, perfectly?
Yes, sir. Yes, Vinod, it is audible.
Yes, sir. Yes, sir. Yes, sir. Okay. Right.
Little bit, you can increase some voice level.
Okay, sir. Okay. Is it fine now? Is it fine now?
Yes. Fine.
Yeah. Yes, sir. Yes, sir. Right.
Thank you.
Okay. And I request all participants to be interactive so that you can post your queries in the chat box. Okay. And also interimly, let us have the discussions. Whatsoever the questions may be, feel free to interact, because in this kind of FDPs, we should spend time for interaction as well. Okay. So with this, we shall proceed with the transition of manufacturing systems. If you see the transition, it started with the craft manufacturing. As we all are familiar, craft manufacturing is where the specialists, in the sense they are the field experts, they are involved in the manufacturing activities. For example, like pot making, they are specialists in that particular area. So they go ahead with the manufacturing activities, and accordingly, the skill set will be transferred to the further generation. So they are the key people who have expertise in that particular domain, and they could do that particular task. Not much technological intervention will be there. Next, moving further with the mass manufacturing, it's based on economies of scale. Okay, so wherein our focus is on high volume production with limited product variants and so on. Wherein repetitively they try to manufacture products, and there will not be much product variants. It's repetitive manufacture of similar products. And also we have the concept of assembly lines, dedicated assembly lines, dedicated product lines, which can take care of manufacture in line with the customer requirements and so on. And also here the workforce, their skill set, if we analyze, they have very good expertise, in the sense they are specialists and they develop expertise as a result of repetitive manufacturing task. Next comes lean manufacturing, where the focus of lean manufacturing is to minimize waste and eliminate waste, enhance value from customers' perspective, try to streamline the process, synchronize the process, and so on. Next comes agile manufacturing, where the focus is on producing a variety of products in line with the customers' varied preferences, and a lot more technological intervention will be there in agile manufacturing. In lean manufacturing, although the technological intervention will be there, but in agile manufacturing, it is at a larger scale. So Next to agile manufacturing, we had across this manufacturing transition chain, sustainable manufacturing, where the focus is on minimizing the environmental impacts, optimal utilization of resources, and so on. Likewise, the manufacturing paradigm have shifted to sustainable, and now we are moving ahead with smart manufacturing based on Industry 4.0 concepts, wherein we are focusing on complete digitalization, and we have a lot of technological intervention in terms of Internet of Things, cyber physical systems, big data analytics, and so on. Likewise, from craft manufacturing, it had moved towards the smart manufacturing. Okay. So this kind of a manufacturing transition will help us to understand the successive manufacturing paradigms. And whenever we go ahead with a particular manufacturing paradigm, always we have to benchmark with the prior manufacturing system. Say, for example, when we are discussing with the lean manufacturing, most times we'll try to compare and benchmark with the mass production system, its precedence, its predecessor manufacturing system. That's most essential. Then only we'll be able to understand the manufacturing system more effectively. Yeah. Further moving ahead, if you see, now let us try to see the comparison between a craft system, mass system, and lean system. So if you see, the focus of the craft system is more on the task or the activity. Whereas moving ahead with mass production, the focus is on production, manufacturing the product, FDP manufacture of similar products. Whereas from a lean perspective, customer is the focus, customer thought, customer value is more important. Coming to the operations, most likely in craft system, we don't have more items or more variants. Likewise, we may operate with limited variants, and they try to produce in line with the requirements. But in mass production system, we have the batch and queue scenario because the products are getting accumulated. So it will have a batch and queue scenario. Next comes the lean system, where the focus is on synchronizing the flow and pull. So here, synchronizing the flow in the sense that the process have to be synchronized as a part of it. That's most essential. One process and the next process have to be synchronized, and they have to be streamlined so that the product flow will be smooth. And it is based on the pull. That is, the lean system works purely based on the customer demand. We try to produce to the customer demand. It's based on the concept of the pull system. Next, if you see the objective of craft, mass, and lean, in craft, we have mastery of craft. That means that they develop expertise. They are specialists in the field. Coming to mass production, the focus is reducing the cost. In mass production, we have a particular concept called economies of scale, which states that when we increase the production volume, the unit cost of a product comes down. That will happen. That trend we can observe in many of the illustrations from the market. When a new product is being introduced, the cost is high, but over the period of time, the cost comes down gradually to the extent possible, all because of this economies of scale. When we increase the production volume, then accordingly, the unit cost of product comes down, and accordingly, we need to focus on enhancing the efficiency as well. Then with the lean system, our focus is to eliminate waste and add value. Yes. Now coming ahead with the quality aspect. In craft, it's an integrated aspect in the sense it is that the craft is an integrated quality is an integrated aspect of craft system as a part of it. Whereas coming ahead with the mass system, we do inspection, but the form of inspection we do is slightly different in the sense through inspection we try to fulfill the quality, and we may do the source inspection, that is raw material inspection, and maybe like inspection at the end we try to do. Okay. And later it had been modified further as kind of a stage inspection and so on. as a product. Okay. Likewise, a lot more changes have happened. And in lean system, quality is an included element. That means quality is an included element of the system. That means we try to adopt the kind of in-process gauging based inspection. That means concurrent with the manufacturing activities, inspection activities should happen. So we try to make the inspection activity as an included element of manufacturing. So concurrently, we try to ensure that through we have appropriate gauges being designed, which will take care of this aspect. That's why we say through design methods, through procedures, we try to ensure quality. Next, further moving ahead with the business strategy in craft system is customization. In the sense, we can't say as a higher form of customization, but maybe a limited form of customization. That is, they do handle few product variants and they focus on customized designs. Coming ahead with mass system, the focus is economies of scale, which we discussed earlier, and we try to automate the assembly lines, also called the production lines, because we are focusing on the repetitive manufacturing of the products. So accordingly, we try to automate the production line. Whereas in lean system, it's about the flexibility and adaptability. So flexibility in the sense, if we have a particular layout being designed for a particular product, that layout need to be modified in order to produce another variant of product. Likewise, in the same layout, we should be able to produce few variants, maybe 2 or 3 variants. Likewise, we need to produce, for which we take the help of production tooling. The production tooling have to be modified, where we take the concept of single minute exchange of dies, which we'll be discussing, whereas it facilitates the quick changeover of the tooling. And adaptable in the sense, such kind of production lines must be adaptable to these varied requirements of customers. It can't handle a higher variety of requirements, but maybe like limited varieties of requirements and so on. That's why we call it as the flexible and adaptable lean system. Next, further with regard to the improvement, if you see in craft system is a master-driven improvement, because the specialists repetitively they do the task and they have expertise, so it's called master-driven. Whereas in mass production, it's called expert-driven, because they do repetitively the same type of task and they become the experts in that particular operations, also called the facility handling. So accordingly, they become experts, and it's expert-driven improvement. And in lean system, it's worker-driven improvement, because if you see in lean system, we need to focus on innovation and the kaizens. We call kaizen as nothing but the 2 Japanese terms which mean improvement on a continuous basis. K and Zen, improvement on a continuous basis, we call continuous improvement. So it is based on worker-driven continuous improvement. So in the sense that improvements the workers have to bring about, that solutions the workers have to think and they have to bring about. That is most essential. That's why it's called a worker-driven continuous improvement. Okay, maybe till this stage, any questions from participants? Okay. So if there are any questions, kindly you may unmute and you can ask me. Are there any questions?
Participants, please interact with the speakers. Hello, Vinod?
Yes, sir. Let me proceed, sir. Okay. Yeah.
Okay. So I'm having doubts. Suppose
please, sir.
mass production to any management or any management technique we are changing from one system to another system.
Okay, sir.
Okay, so maybe it is totally related to customer oriented or related to product oriented?
Sir, in the sense, the kind of the that customer requirements will get translated to that product-based requirements, and accordingly, it will help us to bring about any kind of a change. Let me give an example, sir. We are going ahead with manufacturing a particular variant of product. Yes. Suddenly, some kind of change in requirement from customer perspective is coming. So accordingly, it brings about a change in the product design. It brings about a change in the process design. Accordingly, I may have to explore the process plan. I have to explore the sequence of process, and accordingly, I need to bring about the change. So definitely, when I want to change over from one kind of a setup to the next setup, I have to take a management concept. Say, for example, the quick changeover, a manufacturing management concept I may have to adopt, and accordingly, we need to deal with the customer requirement. Starting from a customer requirement, it will be decoded further to design requirement, process requirement, and accordingly, any change in the management or technology tool we need to adopt.
So maybe the ambassador car, they moved out of the market, isn't it? So maybe due to this reason, because they are not changing, not meet the requirement of customers.
Yes, sir, that could be one of the reasons. Sir. And another thing is the thing, but an advanced variant has dominated the market. Sir. Okay, because the new variants keep coming, and accordingly, that particular product model is going obsolete. Then the next product variant has taken over. Sir. Yeah.
Okay. Can you, sir?
Yeah, fine, sir. Okay, thank you. Okay, now if you see the industry's concerns, okay, one perspective we have the government policies, because government policies will help us to make certain changes. Say with regard to lean manufacturing, Ministry of Micro, Small and Medium Enterprises, they had a policy on lean manufacturing competitiveness scheme, LMCS, wherein they provided grants for the industries to implement lean manufacturing, even small scale industries. Many small scale industries have adopted. Okay, even we were involved in some of the cluster based project as a part of this LMCS, wherein the industries, small scale industries as a cluster, maybe like 5 to 10 industries being put together as a cluster. When they are being formed a cluster, they can submit the kind of a proposal to the MSME ministry, and accordingly, from the ministry, they can get a grant. Maybe like the ministry can provide about 70 to 80% of the project cost, and another 20% the respective industry has to take up. Likewise, the government policies are bringing about the changes in the manufacturing systems. Next comes the global competition, because the competition we have is such a very large scale, and the intensity of competition is increasing, and we have numerous players for the product. For the same product, we have several players, not only from national level competition we have, but maybe like the global competition we have. We have numerous international players also for the products. Next, the organization is accountable to the shareholders, financiers, stakeholders, and so on. So that accountability is also very, very essential as a part of it. Then another end, we have the input cost is increasing, say the material cost, energy cost. Likewise, they are increasing as a part of it. Then comes the competence of employees, because the competence of employees, as I have shown, the craft system cannot be applied to a mass production, or the kind of expertise what they have in the mass system cannot be applied to a lean system. And whatever they have with regard to a lean system directly cannot be applied to a smart manufacturing system. Likewise, it's changing a lot as a part. And apart from that, if you see, the sustainable improvement is also very, very essential. The sustainable improvement, in the sense, we have to sustain whatsoever the improvements, say some kind of a changes we have done. That change has to be implemented, and further it has to be sustained. The improvement have to be on a sustained basis. That sustenance is very, very important. Say, for example, I have done a 5 years based modification. If I am able to sustain the modification, is fine. Otherwise, if we go back to the original stage, it's very difficult. So the sustainable improvement is very essential as a part of it. Yeah. Now let us see lean manufacturing. Okay, there were some experts who might have given some kind of insights on lean manufacturing, but I would like to provide the insights from a different perspective. If you see lean manufacturing, it originated from the Japanese Toyota production systems, TPS we call, and also we call by just-in-time concepts, where the idea is that whenever we receive a customer requirement, the manufacturing should happen and the product has to be delivered to the customer on time. That's most important. Everything should happen on time. That is it. On that particular time only it has to happen. That on time is very, very essential. Okay, from these systems, lean manufacturing concept had emerged, and It had been applied across the diversified sectors and is having very relevance with regard to Industry 4.0 system. Now, as a part of Industry 4.0 implementation, we are working with the industries with regard to the lean concept. So it is more essential because it has traveled from the third generation requirements to the fourth generation requirements. Anyway, tomorrow I have a session wherein I'll be able to discuss all these things from an Industry 4.0 perspective. So if you see, the lean manufacturing, it's called an integrated manufacturing system, where the focus is to maximize capacity, utilize the capacity that is based on need. Without need, the capacity should not be utilized. And also we should explore about the reutilization. Say, for example, the kind of materials, kind of auxiliary materials, whether there is a scope for reutilization, we need to explore. And we need to control the inventory. Minimizing and eliminating inventory is very, very essential. So the buffer inventory have to be controlled through what means. It is nothing but minimizing the variations in the system. The fluctuations in the system, the variations in the system have to be minimized. So what could be a variation? Maybe say, for example, I have a particular shift, a group of workforce is being involved. I have another shift where the next group of workforce will be working. The kind of interaction between the workforce and the facilities, it is contributing to the production and productivity. So such variation should not influence the production that is being defined. Say a shift is being designed for 1,000 units. It has to produce irrespective of these variations. For an example I mentioned. So as the lean theory is based on this elimination of waste, which is called by the term muda. It's a Japanese term, muda, which means waste. We need to minimize the waste. As per the lean theory, we have 7 forms of waste. And apart from 2 other more forms of waste are also being included in this thing. Anyway, we will discuss. So these are the 7 forms of waste we need to consider as per the lean theory. Okay. So unnecessary transportation, unnecessary inventory, unwanted motion, waiting for any kind of a task, producing more than what is required, then processing more than the requirement, and the non-conformities or defects. These are the 7 fundamental ways which we are very much concerned about as per the theory of lean manufacturing. So let us discuss spend some time and discuss about the 7 ways which are very, very essential from the viewpoint of lean manufacturing. What is the transportation waste? Transportation has to happen, but here we mean unnecessary transportation of materials, sub-assemblies, and other entities which happens in the manufacturing layout. Such unwanted or unproductive movement of materials, sub-assemblies will account for this transportation waste. Okay. Next, inventory. Inventory is nothing but the stock of goods. In lean theory, if you see, there are 3 forms of inventory we'll be discussing. One is raw material inventory. Next is in process, there is work in process inventory. And we do have finished goods inventory. So there are 3 forms of inventory: raw material inventory, work in process, and finished goods inventory. So inventory in any form is not desirable, and we need to control the inventory as a part. Because if we do not control the inventory, it will contribute to the it will impact the lead time. But anyway, we will discuss in detail about that. Okay, so inventory in any form has to be eliminated, minimized and eliminated. And the third one is motion waste. Motion waste is nothing but unproductive or unwanted movement of the workforce, which happens in the layout. So definitely the movement of workers is needed, but here we mean unwanted or unproductive movement of the workers. Say if the layout is not being designed well, such unwanted or unproductive movement will happen. And here, if you see in the industrial context, there are 2 forms of workers. One is active worker, another one is support workers. Active workers are nothing but who are involved in actual manufacturing. They are being assigned to a particular machine tool, and they have to be at an interface of machine tool, and they need to take care. Another type of workforce is called support workers, who will help the active workers as a part of executing the activities, who will support them. So such movement of the active workers is very, very essential. So the movement of support workers, okay, we can analyze and optimize, but the movement of active workers should be optimal. Definitely, we have to optimize the workforce, active workforce movement. That is more concerned with the motion waste. Next come waiting or delay, which happens for a variety of reasons. I may wait for material, maybe like sub-assemblies, some instructions, some standards. Likewise, for a variety of things, this waiting or delay happens, which is not desirable. Yeah. Next is overproduction, producing more than what is needed. That means without any need, we are trying to produce, for which there is no immediate taker. There is no demand. Such things when we try to produce more than what is required, because it is going to lie as an inventory. And over the period of time, the product may become obsolete. Okay. Because lean is purely based on pull principles, pull system. That means it is working based on the customer requirement, customer demand, customer pull. That's about the lean system. Whereas the mass production system, when we take, it's based on push system because it's working based on the market forecast. That forecast data is an input, and accordingly it tries to produce. And the products will be pushed to the market, but they are not sure whether they're able to sell all the products or not. That will happen in the case of a mass production system, which is based on push system. Next is over processing. Okay, so we try to do some additional processing which the customer didn't ask for. If you do something which the customer didn't ask for, customer will not pay for it. Say, for example, in a production drawing received from a customer, it had been clearly given the tolerance, which will help us to select the manufacturing process and produce products. Say I'm going for a process which is more precise than what the customer has asked. From the manufacturer's viewpoint, we may tell the product value got improved. But from customer's perspective, they don't agree and they don't pay for it because they didn't ask for. That's the thing we need to understand. Here, customer requirement, very clearly we need to understand and further convert to design requirement and process requirement and so on. Next, we do have defects or some kind of non-conformities. We have non-conformance to the requirements. So the defects may be in any form, maybe it can be a scrap or rework or rejection. Again, it is happening due to improper understanding of customer requirements. So the defects also we need to control. So these are the 7 forms of waste as per the theory of lean manufacturing. Apart from that, we have 8th waste, which means underutilization of workforce creativity, or otherwise it is called untapped creativity of workforce. What it states? Lean is based on innovation in terms of process innovation. So here the workforce competence is very, very essential. So such creative and innovative solutions need to come from the workforce. If you don't utilize the creative thought of the workforce, then it becomes a waste. Okay. Next, there is a 9th waste which is being added, which is called environmental waste. That is nothing but we are trying to utilize the resources more than what is needed. So accordingly, it will contribute to more environmental impacts and kind of emissions and other aspects as a part of it. So that needs to be taken care as a part. So we need to take care of that environmental waste. But if you see, the 9th waste will be taken care by the sustainable manufacturing system. Lean by and large will handle the 7 forms of waste plus the 8th one also it takes care. Okay. That's about the waste which happens in manufacturing process. Okay. Before we move ahead, okay, any questions to this stage with regard to the waste theory and so on? Any questions? Maybe 1 or 2 quick questions we can take. Any questions from participants? Okay, let me proceed. So as I mentioned, lean is concerned with eliminating the wasteful process steps. And it tries to improve the speed. Improve the speed in the sense, it will, that the speed has to be regulated based on customer demand. The system should not go very fast or it should not go slow. It should go at an optimal speed at which the customer has asked for. And also the capital utilization may be lesser because maybe in the from the viewpoint of industry 3.0, not much technological intervention will be there. Okay, so limited technological intervention. And the idea is that if we try to reduce the process time, but we'll be able to bring the product the time which the customer has asked for. So that compliance. Yeah. Next, we will go ahead with discussing further about the term lean and lean manufacturing. So as we discussed, lean is focused on identification of the kind of waste involved in the process. And it is a business philosophy which is focused on continuous improvement. So continuous improvement, Kaizen, it's based on a Kaizen approach. And it tries to improve the process irrespective of the type of the product. Whatsoever may be the product, maybe an automotive product, electronics product, maybe an aerospace product, or chemical products. It can be any kind of a product. But this philosophy is about the facilitating the continuous improvement. Okay. And as we mentioned, the lean tries to enhance the speed, but it does not produce at a very higher or very faster speed. Because if we try to produce well ahead of the schedule, it will become an inventory, either at the manufacturer end or at the customer end, which the customer also will not accept. Okay. And here the cost reduction will happen. So how the cost reduction is happening is because of this elimination of waste and through value addition. The cost reduction will happen. And as I mentioned, it can be applied to any kind of an industry, maybe automotive components, aerospace components, electronics components, maybe a chemical processing industry, not only product-based industries, but also process industries and so on. Right. So here, in order to understand the lean system, we should have an understanding on its elements, set of tools and techniques, and governing rules that will eliminate waste and value creation. So here, in my presentation, I'll be focusing on these three perspectives. One is the elements we will discuss, then we'll have a discussion on tools and techniques and further governing rules. And also the lean manufacturing implies it's a speedy process. Already I told speedy means in line with customer demand. That is most essential. And smooth. That means we are trying to minimize the fluctuations in the system. And economical manufacturing. That means we are exploring the perspective for cost reduction and so on. That's happening. Yeah. Okay, so as we discussed earlier, the term waste is nothing but kind of an entity that consumes resources, but do not add value from customer's perspective. So the waste could be in any form, like maybe a high inventory or scrap, could be a rework or the low productivity, downtime, or it may be a poor yield, the elongated lead time, and waiting for inspection, waiting for some kind of instructions, and trying to utilize more labor than it is needed, and so on. All these are nothing but the examples or the forms of waste which may happen, all because of the not understanding the customer requirements and also not following the procedures as a part of it. All these could be mapped to the 7 fundamental waste as a part. Okay, so these are all the different forms of waste which happens in the context of manufacturing. Okay, as I mentioned, we'll be discussing about the elements first. There are 5 elements of lean manufacturing called the customer value, value stream, value flow, customer pull, and perfection by continuous improvement. These are the 5 elements of lean manufacturing, and they are based on a chronology. That means they are being chronologically being formulated, and they have to go by a particular chronology. And ultimately, these elements can be applied to any kind of a process, and it facilitates continuous improvement. So these are the 5 elements, as I mentioned: customer value, value stream, value flow, customer pull, and perfection by continuous improvement. Let us discuss them. So what is customer value? Here in the context of lean system, the customer pays money. In turn, they want value. That means we need to focus only on those activities which add value from customer's perspective. That's more essential. And we need to have a proper understanding of the customer activities. All these are very essential. Next come, having understood the customer value, next we will define the value stream. Value stream is nothing but the stream of activities which happens in manufacturing from the receipt of the customer requirement till the product is being delivered to the customer. It contains various steps, various activities, various processes in line with fulfilling the customer requirements. Such a sequence of activities is called the value stream. And in a value stream, if you see, there will be 3 types of activities, which is called value adding activities. Second one is necessary but non-value adding activities. And the third one is non-value adding activities. What is value adding activities? It's also called customer value adding activities. Say, a different manufacturing process we do. Maybe I do a turning process, milling process, grinding process, and so on. So they are nothing but the different process activities we do in order to fulfill the customer requirement. So they are value adding activities. Second one is necessary but non-value adding activities. Otherwise, it's called business value adding activities. That means those activities do not add value to the product directly, but they are essential for product completion. Say I do some inspection. Inspection is not going to add value, but it helps us to fulfill the check the requirements, and it tries to complete the process sequence. And if you see some mandatory inspections, some kind of quality inspections, as per the quality management system, we do some mandatory inspections and all will come under necessary but non-value adding activity. And if you see process industries and all, they will take the certification from the government agencies and so on. That and all will come under necessary but non-value adding activities. Third one is non-value adding activities. That means those activities which do not add value from customer perspective is called a non-value adding activity. That is the 7 forms of waste we have seen. All such activities are not adding value from customer's perspective. They are called non-value adding activities. So in a typical value stream, we have value adding activities, necessary but non-value adding activities. Otherwise, they are called business value adding activities. Third one is non-value adding activities. Right. Next, having defined the value stream. So in the sense now the value stream, we can understand the sequence of process from the receipt of customer requirement till the product is being delivered to the customer. Every stage, we need to ensure whether value is being added. In turn, the cost is being incurred, but in turn, value is being added. Say I do a grinding process. Cost is incurred, but value is being added from customer's perspective. And the product we are trying to bring closer to that of the customer requirement. That is called value stream, where every stage we are able to ensure the cost is incurred, value is added. Next comes value flow. So having defined the value stream, having analyzed the value stream, next we will move ahead with the value flow. That is nothing but the product which is manufactured using the value stream based on the customer requirement. So here the product that is manufactured using value stream based on the customer requirement is called value flow. So the value flow must be smooth. That means without any bottlenecks. Okay, what we need to do in order to make the value flow to be smooth. So what could be a bottleneck? Bottleneck is nothing but a kind of a barrier or a hindrance which impacts value flow. So if you see the kind of bottlenecks, okay, so the plant layout can be a bottleneck. So if the layout is not being designed properly, it will contribute to the unnecessary transportation and unnecessary movement of the workforce also. So it's a kind of a bottleneck. So the layout has to be designed very perfectly. Layout design is very, very essential. Next, if you see the quality of raw materials can be a bottleneck. If the quality of raw material is not perfect, then it may impact the further activities as well. So how we can ensure raw material quality? Here, we can't check the quality of raw material because if we check the raw material quality, it consumes time. It is not a value adding activity. So the supplier has to certify that. Supplier has to ensure that. Next is product quality. So how we ensure product quality? Here, I told in my earlier slides also. Could someone, I would like to hear from participants, how we ensure quality in lean system? How quality is being ensured? What kind of inspection we do from participants? I would like to hear. What type of inspection we do with regard to lean system? So here we go ahead with the kind of a modified form of stage inspection, which is called in-process gauging based inspection. That means we try to provide the in-process gauges which can check different quality parameters as a part of it. And the inspection is an included element of manufacturing. That is how we try to ensure quality. Okay. Next, if you see, the product design could be an bottleneck for value flow. That means we need to have an understanding on the customer requirements, proper understanding on customer requirements. They need to be converted into design requirements and further process requirements and so on. If there is any kind of an an error or a wrong understanding of customer requirements will contribute to some kind of flaw, then the design will not be in line with customer requirements. Once the design is not being in line with customer requirements, then there will be a deviation in the process requirements, and ultimately the product being manufactured will not be in line with customer requirements. So we need to have a typical cross-functional team to understand the customer requirements. That's called product design. That's how a product design is a bottleneck for value. Next come tooling, production tooling. So here, the tooling has to be supported with the concept of quick changeover or SMED, because if there is more time is being consumed in changeover of tooling, it may impact value flow. So definitely, we try to go ahead with the kind of production tooling wherein we need to incorporate this single minute exchange of dies and quick changeover concept so that the exchange time between the setups will be faster, so that will not lose time and will not, the lead time will not get affected. The next bottleneck could be the downtime. What is the downtime? Downtime means there is no interaction between the machine tool and the component. For what reasons the downtime is happening? Maybe the non-availability of the workforce, non-availability of the machine tool, or maybe like waiting for some kind of instructions, waiting for some kind of sub-assemblies, waiting for tools, like which for a variety of reasons it happens. We need to analyze why these downtime is happening, for what reason it is happening as a part of it. We need to analyze and we need to find out the ways and means to take care of it. So the downtime need to be avoided as a part. So we need to do a typical analysis. Maybe I can do an FMEA, failure mode effect analysis, or maybe like I can draw a cause and effect diagram. And then I can try to spot out the root cause for the downtime. I can minimize it, eliminate it, and we will do fulfill this problem with regard to the downtime. Okay. Next, maybe like maintenance of machinery and equipment could be a bottleneck for value. Say, for example, we do have scheduled maintenance, and that will happen as per the time frame. And we need to explore the ways how the maintenance activities can happen concurrent with manufacturing activities, concurrent with production activities, how it can happen. We need to explore. Because now we have advanced forms of maintenance procedures and maintenance methods, so that we can try to make it happen parallel as a batch. Then accordingly, the time that is consumed with regard to the maintenance procedures and maintenance philosophies also could be controlled. Okay, after taking care of the maintenance of machineries and equipment, next we shall explore about the inventory, because inventory is a kind of a bottleneck. In any form, the inventory is not desirable. Maybe it can be an raw material or a work in process or finished goods. But if you see the work in process inventory, a lean system can very effectively handle work in process inventory, because raw material inventory and finished goods inventory are strategic aspects for which we don't have much control. It's fine. Whereas work in process inventory could be much streamlined across the process as a part. So that is more effective. So that we need to ensure. So inventory as a bottleneck had to be taken care. Next comes the adopting the visual workplace. That means visual communication. In lean, we should try to make this communication flow also smoother, so that the communication and information flow is also very essential along with the manufacturing activities to happen as a part of it. That also need to be taken care. So once we take care of all these bottlenecks whatsoever we have discussed, then we can try to make the value flow smooth. Once the value flow is being made smooth, next we focus on customer pull. Already we discussed some insights about the push system and pull system. Pull system is working purely based on the customer demand, whereas push system is working based on the forecast demand, market demand. Here, the market demand or the forecast data is one of the secondary parameter with regard to the lean system. It will help us in planning the materials. Though we go ahead with the just-in-time concept, every time we cannot be 100% just-in-time industry. So for planning the raw materials, that may help us as much. Next comes, once we try to transform the push system to pull system, so we are trying to produce to the customer demand in terms of the number of units and in terms of the number of, attributes, in terms of the time frame. Then we try to transform the push system to pull system. Next come perfection by continuous improvement. That means we need to sustain whatsoever the improvements being made. We need to go for the Kaizen-based approaches. We need to adopt the standard procedures. So for which, before sustenance, we have to standardize. Adopting the standard procedures and standard instructions will help us to retain the improvements as a part of it. So these are the 5 typical elements of a lean manufacturing, starting from customer value, value stream, value flow, customer pull, then perfection by continuous improvement. All these 5 elements are based on a chronology, as I mentioned, because value flow cannot happen before value stream. Value stream cannot happen before customer value as a part. So that is very, very essential as a part. Okay. Are there any questions from participants to this stage? Are there any questions?
Yeah, participants, any questions? Vinod, I'm Karthikeyan here.
Yes, sir.
Yeah, out of these 5 elements, which one you have to give more important?
Sir, all 5 elements are essential, but the customer value, the first element, we have to take utmost care because that is forming the input for all other elements in sequence. So understanding the customer's requirements is in a more effective way is very, very essential because it will further drive all other elements. But all elements are equally important, sir.
Okay. Suppose nowadays all the automotive industry they given the customized design. Suppose customized interior, customized color like that.
Yes, sir.
In order to satisfy the customer, isn't it?
Yes, sir.
Okay.
Yeah, yes, sir. It's what you're telling is fine, sir. But that the customized designs also, from starting from a base requirement, those requirements will be configured, and accordingly, that the process changes and other things also need to be taken care. Whatsoever the design and process related changes also need to be taken care, sir. For which here lean system will help us.
Certainly.
Sir, I'm Vijay Kumar, sir.
Yeah. Yes, go ahead.
Sir, one doubt. What is the exact difference between over processing and over production, sir?
Overproduction and over processing, you're asking.
Difference between
Yes, overproduction is nothing but producing more than what the customer has asked. The customer has asked for 500 numbers. If you are producing 550 numbers, additional 50 numbers there is no demand for them. That is called overproduction. Say overprocessing in the sense a customer has asked for a particular component for which they have mentioned the kind of tolerance. That is nothing but which process I need to go ahead with that.
Okay.
Say, instead of that, I go for a higher precise process. Say, for example, as a part of finish, a grind finish may be asked, but I go for a honing finish. Okay, I may say that I have provided the additional precise attribute, but the customer didn't ask for. Customer will not pay for it. Got it, sir?
Sir, may I?
Okay,
May
got
I?
it. Okay.
Yes.
Sir, Mangesh Sana from Pune.
Okay, go ahead.
I'm an MBA faculty.
Yeah.
Sir, when we were in school, we used to sharp our pencils with a sharpener.
Okay.
And majority times trying to get a very sharp tip for the pencil, we used to move further and the pencil used to break down. So
Okay.
that would be an easy example of over processing.
Yeah. Yes. And also I would like to mention in the same example, now that the design of the sharpener is being made in such a way that the removal of that wood material also happens very perfectly, so that even the kids by mistake, if they try to put in a wrong way or something also, that sharpener design will not allow testing. So such modifications are also being made with regard to that particular product. Hope I answered your question, sir.
Yeah. Then we will be able to realize highest customer value for that product.
Yeah. Even with the simple product, such features are being incorporated.
Sir, I have a question.
Yeah, go ahead, madam.
Sir, do you think that customization makes lean manufacturing more difficult as compared to a production line, which is more standardized, following more of an assembly line?
Yes, madam. If you see the manufacturing scenario, that is in industry 2.0, our focus is on mass production. There is nothing but a dedicated product line will be there for a particular product. But in industry 3.0, where we utilize the electronics and information technology, where we had, before moving ahead with industry 4.0, that the scenario of that mass production itself got changed to mass customized scenario, mass customized manufacturing, because the customer requirements are not in bulk. They are not focused on one particular variant. Say, for example, in consumer electronics domain at all, if you take that designs, numerous products are there as a part of it. Then each one requires unique design attributes. Accordingly, we need to go for that tailoring the production line in line with the customer requirements, in line with the design changes. So it is inevitable. So here lean system also will help in customized designs, but to a certain extent it can facilitate, beyond which it will give rise to agile system, because agile system can handle more effectively this customized designs because of deployment of technologies is more with regard to agile system. Hope I answered your question.
Yes, sir. Thank you, sir.
Any further questions from the participants? Sir, I could see some messages in the chat box, but concurrently, since I'm sharing the content, I may not be able to see this chat box. Could you see, sir, any of the questions in the chat box being posted?
No, sir.
Okay.
That one, Savila.
It's fine. So any further questions from participants? Okay, if not, let me proceed. Then interimly we'll take up. Okay, so as we discuss these things, okay, let me take this kind of a value stream which I had shown. Some examples, let us discuss. So I told there are three types of activities in a value stream. One is value added, second one is business value added, third one is your waste or non-value adding activities. As I mentioned, in that value adding activities, only those activities which you do in order to fulfill value from customers' perspective. Say, for example, I have a sequence, product sequence, process sequence. I have a turning process followed by a grinding process, and further I have maybe like an inspection and other kind of process. Those activities, the turning, grinding, they are value adding activities. But the inspection, which comes next to grinding, is not adding value, but it is essential for completion of product manufacture. So it's a business value adding or necessary but non-value adding activity. It is not adding value, but it is essential for completion of the process and product manufacture. Next come non-value adding activities, which is not at all adding value from customer's perspective as a part of it. So the 7 plus another 2 forms of waste we had seen, they are nothing but the non-value adding activities. Okay, I will tell 1 or 2 examples now, and you please tell me which category of activities it belongs to. Okay. So some kind of waiting which happens for the inspection. Waiting happens for inspection. Which form of waste? Is which form of activity here? Waiting for inspection. Participants?
Hello, participants. You can unmute themselves and react to the question. You can reply to the questions.
Activity necessary for completing the process?
Not, madam. If we
It's
see,
a waste?
it is nothing but it's nothing but it's
Okay.
waiting for inspection.
Always
if
a
this is
waste.
inspection,
Then
it will
it's a
come under,
BVA.
as you mentioned, it will come under BVA.
Okay.
But if this is a waiting which happens for inspection, so it comes under the third category, non-value adding activity. Okay, thank you, madam. Say for example, a process industry is there. For the process industry, they have to get the clearance from regulatory agencies. Okay, the procedure, they have to get a clearance from the regulatory bodies and the government authorities they have to get. It will belong to which kind of activity?
Sir, is it business value adding?
Yes, madam. Fine, correct. Business value adding, because it is not adding value from customer perspective, but it is essential to complete the manufacturing loop. And another point I would like to mention is nothing but the customer will pay only for the value adding activities, but there is an exception. Say for business value adding activities, that is necessary but non-value adding activities, in some customer will not pay for that also, but there is an exception to this. Say for example, as I mentioned an example, they try to do some procedures for getting clearance from regulatory agencies, the procedures for mandatory inspections, compliance with quality management, compliance with the environmental management, all these mandatory and regulatory activities, the industry does. A portion of will be charged from the customer. In that context, the customer will pay for necessary but non-value adding activity. That is the only context where the customer will pay for necessary but non-value adding activity. Otherwise, they pay only for value adding activities. This is the point I would like to mention. Okay, next. As we have discussed about the bottlenecks, everything I conveyed. Okay, so now let us see the comparison between a mass system and lean system. Because in order to understand the system, we need to benchmark with its predecessor system. Okay, if you see in mass system, there will be buffers of inventory. Raw material inventory will be there, in-process inventory will happen, unfinished goods inventory will happen, and so on. But in lean production, the objective is to minimize inventory and minimize waste. It is the focus of lean system. Similarly, if you see in mass production system, in lean, we are saying it is just-in-time delivery. That means delivery on time. If we deliver well in advance, customer will not accept because it will become an inventory at customer end. If we late delivery also, the customer will not accept. On-time delivery only is needed. Whereas in mass production, it is called just-in-case deliveries. That means early delivery, they may be happy. Sometimes late delivery, for some reasons, the manufacturer will say and the customer will accept. And sometimes it will be just-in-time, on-time delivery also. All these three types of delivery mechanisms may happen in a mass production system. Similarly, in mass production system, we are doing that quality inspection and all. We will go ahead with the concept of acceptable quality level. We do this kind of statistical process control approaches, like we try to draw an operating characteristic curve and so on. Then we try to ensure quality. Whereas in lean, it is perfect first time quality. That means every activity which is being done have to be right first time. Similarly, when we do likewise, the product quality will be ensured. It will have first time perfect quality. Then in mass production, it is based on the Taylor's production system. That is nothing but we might have studied about the differential payment scheme, work study, method study, time study, and so on, based on Taylor's production system. In lean system, we call our focus is on to promote the teams, worker teams, bringing about the worker involvement, and so on as a part of it. That means we should not think that Taylor's concept are not applicable for lean production, but Taylor's concept are also equally applicable. We do method study, we do time study and all, but we go ahead with the Taylor's concept in an advanced way. Say the differential production system which the Taylor has contributed. We are taking ahead with a different approach in lean system. We go ahead with the suggestion scheme and the incentives for innovation and so on. We go ahead. Next, in mass production, our focus is to maximize efficiency. That means we have resources, we utilize them, we try to produce the product, and we say it's efficient. But whether there is a definite demand or not, it's not sure. Whether we'll be able to sell the product or not immediately, you're not sure. But in lean system, it is about flexible production systems. In the sense, the flexibility of the process will be ensured. The process will be flexible. Production line will be flexible in order to take ahead with the customer requirement. In mass production, they call a term called if it ain't broke, don't fix it. That means you encounter a problem, issue. If you're not able to rectify it, they will leave as such. It will be explored, but it will not be solved. But in lean production, it is continuous improvement initiative. Kaizen. Again and again, it's a Kaizen-based approach as a part of it. The improvement will be on a continuous basis. Are there any questions with regard to the comparison of mass production with lean production? Are there any clarifications? Okay, let me proceed further. Now, yeah, are there any questions?
No, sir.
Fine. Next, we will go ahead with the tools and techniques of lean manufacturing. And having completed the elements, we'll be discussing about the tools and techniques. We'll be discussing about the primary or basic tools, which is 5S, total productive maintenance, value stream mapping, then a set of secondary tools. So primary tools or basic tools, they are essential for lean implementation. Any lean implementation will start with a primary or basic tool. In that we have 5S, GPM, then we do have process mapping and value stream mapping. What is 5S? 5S is a workplace organization technique. That means it promotes organized workplace. It promotes organized way of doing things. It promotes an organized layout. Thereby, we'll be able to ensure the operators will become involved. The workforce will become involved. They'll be able to demonstrate their ownership as a part of it. Such cultural transition we try to bring about with regard to 5S. So 5S are nothing but the 5 Japanese terms, which means Seiri, Seiten, Siso, Shiketsu, and Shishuki, meaning sorting, setting in order, shine, standardize, and sustain. What were they? Seiri is nothing but we try to segregate the things which are in use, which are not in use. We try to do, first we try to identify the items not in use category-wise. We attach red tag to those items not in use. Then we'll keep the red tagged items in an identified area. Then we'll take the disposal action. Like this, we'll proceed. Next one is Satan. Here we'll try, it promotes orderliness. We try to keep the items in a proper sequence so that they can be retrieved for usage. So the sequence we need to ensure as a part of it. That orderliness we try to ensure. It is not only with regard to the shop floor, but also with regard to the supply chain process and maybe like the materials procurement process, likewise the quality assurance process, production process, and so on as a part of it. So in Satan, we try to use the concept of shadow board and all, which I'll show some examples in due course. So Satan is about ensuring orderliness, putting in a proper sequence as a part of it. Next comes Siso, which means shine. That means ready for immediate usage as a part of it. We try to ensure the workplace and surroundings are clean as a part of it, so that there is no concept of dirt, dust getting accumulated and so on as a part of it. That's where the focus of shine or Siso comes. So here in shine, we try to arrive at the cleanliness standards, lubrication standards, variety of standards we try to deploy as a part of it. And we go ahead with the routine cleaning, routine inspection and all. Next comes Shiketsu, which is called standardization. Here we will try to standardize the procedures, standardize the instructions, and we try to do the auditing, 5S auditing. So we try to ensure whether all the activities are being done in line with the 5S concept and whether the it is going as per the standard procedures and so on. We try to ensure that we do as a part of Shiketsu standardization. I'll be showing some more insights further. Next comes Shishuki, which is called sustenance. So here we try to create a culture of continuous improvement. We try to create a culture of self-discipline and self-awareness, and we try to sustain the working actions and so on as a part of it. And we try to promote that kind of a culture where the operators will develop ownership as a part of it. And they'll be able to do on their own. That enthusiasm and motivation we try to take ahead as a part of it. So this is the thing, but 5S red tag. Okay, so for the items which are not in use, we will prepare this kind of this red tag will be positioned for those entities, and here it contains all information like what type of an entity it is, and it is nothing but why it is being discarded, to where it has to be moved, and so on. This is nothing but the picture shows the red tagged items, how they are being positioned. Okay, they are being kept in a separate location as a part of it, so that they are being kept in an identified area, so that it will be easy for them to take ahead. They can be disposed of, so that they will not get mixed with those items in use also. this concept of red tagging is also very, very essential. Next, as a part of Satan, we try to follow this kind of a shadow board. If you see on the left, all the tools are being dumped in a toolbox. On the right, if you could see, all the tools are being positioned very appropriately. This is the concept of shadow board. That means it faces that a shadow board will contain the impression or that image of the tool, so that the workforce will be able to position the tool in the right place. If a wrong tool is being positioned, it will not get fitted. That's the idea. So it may seemingly be a simple tool, but it is more effective as a part of it. So this is the concept of shadow board, which is used in Satan. And always in Lean, if you see, we try to have this before-after scenarios. Before scenario will be represented left and after scenario will be represented right. This is the convention we follow in Lean systems. So as a part of 5S auditing is nothing but an act of checking. So different activities we do with regard to the different elements. As a part of SAIRI, whether we do 5S red tags we create or not, and whether the red tagged items are being kept in an identified area or not, we do. And Satan with regard to, say for example, whether we develop this concept of shadow boards, whether the shadow boards are in practice like this, maybe like this example 5S audit sheet we developed in a project, wherein with regard to SAIRI, we had a checkpoint for materials, machineries, visual controls, and so on. With regard to Satan, the indicators for quantity, location, and then here we will have a 1 to 5 scale or 1 to 10 scale we have. Accordingly, we'll calculate the audit score also, and we'll try to find out the area where improvements are needed as a part of it. So as I mentioned, as a part of standardization, we will develop the standard procedures, standard instructions, and we do, and this audit we do, and we represent the audit scores. Through this kind of a spider chart or radar chart. Whatever being shown here is nothing but a spider chart or radar chart, through which we'll be able to represent the scores of all 5S elements. So in a single shot, we'll be able to know what is the score pertaining to SAIRI, Satan, SISO, Shiketsu, Shishuki, which one needs some improvement, what actions we need to do. That we will try to, this as a part of Shiketsu we'll be doing. Okay, so now we discussed about 5S. Any questions with regard to 5S? Participants, any questions with regard to 5S? Kindly feel free to interact.
Vinod?
Yes, sir.
Yeah, it is we can use the 5S concept only for the industries or any other places too.
Sir, it is I can say this is an universal tool, sir. Not only for industries, but also in our day-to-day activity, if you see, we can have many real-life examples, sir. Say, for example, with regard to maintaining the books, how we do in a book rack. Okay, with regard to maintaining the things in our household day-to-day activities, how we are able to position and how we are retrieving back. Because if we don't keep the items in the right place, then it will create more time for locating the item. For retrieving the item, it takes more time. So it's a very practical and real-life tool, sir.
Yeah, yes. Okay,
it is having universal applications.
Yes, I understand that. Participants also please interact with the speaker. Okay, proceed, Srinath.
Yes, sir. Okay, sir. I'll do this. Okay. So any questions, kindly feel free to post in the chat box. Or you can always interact, because the interaction is very, very essential as a part of the lecture program. Okay, so let me proceed further. So having discussed about 5S.
Vinod?
Yes, sir.
The outcome of the 5M concept to be measurable?
Yes, sir. We'll be able to get a cumulative score, sir, based on which we'll be able to find out where in which 5S element that lag is there, and accordingly we'll take the improvement actions, sir.
So that will be converted into points value or converted into money value?
Yes, sir. It will be converted into the points, sir. That based on the analysis of the points, we'll be able to take the actions, and accordingly, once we implement the actions, the benefits will be able to measure, sir.
Yeah, because this is some of the, we can say it is intangible benefits, no? After
Yes, sir.
implementing.
Yes, sir. But we can quantify in terms of the quantitative values also. So say, for example, that how it will contribute to, in one perspective, how it will contribute to the productivity improvement. Say, for example, standardizing procedures, standard procedures. After implementing standard procedures, how much is the productivity improvement? We can measure that. And as you mentioned, the intangible benefits like improvement of morale of the workforce, nothing but bring about the cultural transformation, how the culture had been brought about in the organization. Such intangible aspects also will be there.
Okay, because this is my thesis area, no? So convert the intangible benefits into tangible benefits.
Yes, sir. Yes, sir. Okay, sir.
Thank you, sir.
Right, sir. Right, sir. Fine. Let me proceed with the next.
Sir.
Yeah, please go ahead. Yeah.
Dr. Anand, sir.
Yeah, please go ahead.
Sir, any specific training program available for 5 years auditor training is available, sir? 5 years audit.
Yes, sir. That is the thing. But so there are some organizations who provide training with regard to this implementation. But we can't say this auditing is something similar to that of the regular audit training kind of a thing, so for which we don't have. But as a part of 5 years implementation, some kind of training will be given by the agencies.
Okay. Thank you, sir.
Yeah. Any further questions? Yeah, please go ahead.
Yes. Sir, any organization so far which has implemented in India and they have seen the success, can you just
Ma'am, your voice is breaking, ma'am. Could you please repeat, ma'am?
say any company in India, Indian company which has adopted this 5 years and seen the success, can you just throw light on that?
Ma'am, there are n number of industries who have implemented, ma'am, as a part of it. All industries who have implemented lean concepts, definitely the first primary tool is nothing but 5 years implementation, ma'am. I can say not only larger industries, even smaller industries also they have implemented. I can say almost all industries, definitely they might have implemented 5 years in a structured way or maybe in an unstructured manner. Because 5 years is a universal tool, definitely the industries are implemented. But since you have asked some kind of benchmark industries, I can mention the industries who have implemented lean concepts more effectively. Say, for example, we have previous groups of industries and all, they have gone to an advanced levels of implementation of lean and further tools. They are kind of exemplary industries who have implemented lean tools in specific, maybe as a part of 5 years also. Okay, ma'am?
Thank you, sir. Thank you so much.
Okay. Okay, with this, we shall proceed with the next primary tool, which is called a total productive maintenance. So what is TPM, total productive maintenance? It is nothing but we will try to implement the maintenance activities for machineries and equipments to ensure productivity, to improve productivity on a continuous basis by bringing about the involvement of the workforce. We try to implement. In that, if you see this kind of a TPM concept, in order to understand the TPM concepts more effectively, if you see the historical perspective of TPM concepts, they originated initially from TQM concepts. The TQM concepts, the total quality management concepts, they have been subjected to implementation first, and later they realized that the TQM concepts were not found to be more compatible for this maintenance activities. Then from TQM, they started evolving a separate theory for maintenance activities. It's called TPM, total productive maintenance, wherein by implementing the maintenance procedures more effectively, the productivity improvement had been quantified as a part of it. And it's an excellent tool which helps in improving the productivity. So if you see in TPM, the focus is on the 8 pillars, which we call it as house of maintenance. These are the 8 pillars of TPM. We'll discuss one by one. First one is autonomous maintenance, wherein the operators will be trained to do the maintenance activities on their own. That means some of the fundamental maintenance activities, they have to be trained. They should not depend on the shop floor, that is the maintenance division workforce. So on some of the maintenance activities, they'll be trained so that they'll be able to equip skills, maintenance skills on their own. Next one is equipment and process improvement, where the focus is on enhancing the equipment effectiveness. Here we call a term called a numerical parameter called the overall equipment effectiveness, OEE we call. It is a comprehensive measure for TPM practices. We'll be discussing about OEE measurement. In this equipment and process improvement pillar will try to enhance the OEE of machineries and equipments. So here we try to have, deal with the manufacturing losses. So they are being put under equipment, manpower and material related losses. We try to minimize them, and accordingly we try to focus on the equipment and process improvement. Next comes the planned maintenance. So here, both the preventive and predictive maintenance is very essential. So preventive maintenance, we are all much familiar, but along with that, the predictive maintenance also we try to deploy. Both preventive and predictive maintenance is very, very essential as a part of it. And the predictive maintenance is based on the condition monitoring and other aspects, and accordingly we'll be able to deploy the maintenance actions. So accordingly, the maintenance of machineries and equipments could be ensured. Next comes early management of new equipment. Here, because if you see the reliability curve, if we analyze, it has 3 stages, wherein the second phase is the useful lifetime of the product, and the first phase, some failures may happen during introductory failures may happen, initial phase. Then the last one is nothing but the worn-out failures may happen as a part of it. So here we are focusing on the useful lifetime of the machineries and equipments as a part of it. And whenever a new equipment is being put into practice, the manufacturer is very much concerned about the initial operating period. That's why they are very much concerned about the service schedules during initial period. Yes, sir?
Vinod,
Yes, sir?
why voice is not coming?
You cannot hear, sir? Okay, but it's fine, sir.
Vinod?
Sir, could you not hear me, sir?
It's audible, sir.
We can able to hear you.
So it's audible.
Okay. Okay, thank you. I'm proceeding. So here in the manufacturers, they are very much concerned about the initial operating period of machineries and equipments. So that's why they are very much concerned about the service schedules. They very much require that the service schedule need to be taken care, because during the initial period, the failures may be more. So such aspects need to be taken care during design phase of machineries and equipments. And accordingly, we need to design the machineries and equipment components in such a way that this kind of failures need to be taken care. Next comes process quality management, where this pillar is focused on ensuring that how the conditions of machinery and equipment, the variation in the conditions of machineries and equipment should not contribute to the defects, should not affect the quality. So that quality related issues which comes through the variations in conditions of machineries and equipment need to be taken care as a part of it. That is what the process quality management pillar take ahead. Next comes the TPM in office. It is called office TPM or administrative TPM, wherein these maintenance activities is not only with regard to manufacturing division, but it has to be coordinated through the administrative and support divisions. So such coordination, how we can bring about, that will be taken care by the office TPM. Next comes education and training. In education and training, we have to focus on enhancing the operators' operational skills and maintenance skills. Both are essential. So we need to give a twofold training, one on technical training, other one is on soft skills, like teamwork, interpersonal skills, and so on, communication aspects, and so on. So that this operators' operational and maintenance skills could be taken care. Next comes safety and environmental management, because if you see, providing the safer conditions for the workforce, operating conditions, and also the environmental related aspects. Because the utilization of resources have to be optimal, because it will produce more environmental effects. More resources we utilize than the need, it will produce more environmental impacts. So that also need to be taken care. These are the 8 pillars of TPM. Participants, could you all understand these 8 pillars of TPM? Any clarifications? Is it clear to all?
Yes, sir.
Yeah, fine. Next, if you see, as I mentioned, the overall equipment effectiveness, which is the comprehensive performance measure for maintenance practices. Here, it is the combination of availability, performance efficiency, and quality. When we take the product of availability, performance efficiency, and quality, we'll be able to get overall equipment effectiveness, which indicate the efficiency of the machinery or equipment during its planned loading cum operating time. Let us see the equation which is used to calculate overall equipment effectiveness, which is the product of availability, performance, and quality. So if you see availability, here the machinery or equipment has to be made available. In the sense, we have to minimize the downtime related loss. Already we discussed the different sources for downtime that we need to minimize. Then the availability of machinery and equipment need to be taken care. Next comes performance, where we try to minimize the speed loss. So once we are able to ensure the performance of machinery and equipment is fine, that means the planned production and the actual production will be on par with each other. Actual production should be in line with planned production. That we need to take care. Next comes quality yield, where the defects or quality loss need to be minimized. Then accordingly, the quality yield that we have can be ensured. So as per world-class threshold, if you see, overall equipment effectiveness has to be of the order of 85%. If it is more than 85%, it is considered to be the world-class threshold. And definitely the organizations have to calculate OEE for all machineries and equipment. And they need to find out where the OEE is less. The machineries or equipments where the OEE is less, and they have to analyze as a part of it. Okay, so let us see one more illustration also for overall equipment effectiveness. Before which, if you see some of the conditions which can help in TPM success, it includes first one, equipment effectiveness. How to enhance equipment effectiveness. Next, how we can implement autonomous maintenance. Third is scheduled maintenance. Fourth, skills improvement. Fifth, equipment management. We will discuss one by one. What is equipment effectiveness? Equipment effectiveness is nothing but, as we discussed, the OEE of machineries and equipments has to be as per the world-class threshold. That means we need to analyze the problems with availability, performance, efficiency, and quality as a part of it. And accordingly, we need to ensure equipment effectiveness. Next comes autonomous maintenance. Before which I'll just show an illustration for equipment effectiveness. So here, if you see in this illustration, this OEE is being calculated for a machine tool, drilling and tapping center. The shift time is 8 hours, 480 minutes. In that, planned maintenance time is 25 minutes, downtime is 35 minutes, and setup time is 30 minutes. So when we subtract this maintenance time, downtime, and setup time from shift time, we'll be getting available time as 390. That is 480. When we subtract that 90 minutes, we'll be getting 390. And availability is the ratio of available time to shift time. 390 to the ratio of 480, we'll be getting 81.25% as availability in percentage. Next comes performance efficiency, where the planned production is 200 numbers, but the actual production is 180. So 180 to the ratio 200 will be getting 80%. Then first time pass rate or quality yield is 99%. That means defects are happening to an extent of 1%. So when we take the product of availability, performance efficiency, and quality, we'll be getting OEE as 64%. But as per world-class threshold, it should be 85%. So definitely there is a lag in overall equipment effectiveness. We need some improvement actions. Is the computation of OEE clear to all participants? Is it clear how we are calculating OEE?
Yes, sir.
Okay, now let us analyze. We computed OEE, but we should not stop with this. We should analyze how we can enhance overall equipment effectiveness. Okay, some suggestions from participants, how we can improve this overall equipment effectiveness. Suggestions from your side? I will start. Similarly, you can tell for your suggestions also. See, if you see, the downtime is 35 minutes. If we have more downtime, then availability will come down. So we can analyze what are the reasons for downtime and we can minimize the downtime so that we'll be able to increase availability. Similarly, suggestions from your side for this case.
Yes, the setup time can be reduced by using the jigs and fixture or proper tooling welding device.
Yes, sir. Yes, sir. Yes, sir. Fine, sir. From participants,
trying to improve the actual production. So that is
very good.
Another method.
Yes, because the actual production is only 160 numbers. The organization, they may try to outsource and get them, but they have to find out what is the reason and they have to enhance the actual production. Any other reason? Any other solution?
Planned production, so design and everything, material, raw material in hand, we can go for production. Maybe that planned production shift time may be reduced.
Okay, sir. Okay, and if you see planned maintenance time, they have given 25 minutes. So as I mentioned, the maintenance time activity can be done parallel with production, parallel with manufacturing, so that the planned maintenance time also we can reduce. Thereby, we'll be able to enhance overall equipment effectiveness. So we need to analyze what are the reasons, and after computing OEE, we have to find out what are all the ways how we can improvise OEE. Likewise, we have to analyze and we have to take ahead. Okay. Next, as I mentioned in the conditions, next one is nothing but autonomous maintenance. So autonomous maintenance means operators have to do the maintenance activities on their own. So they have to be trained on maintenance activities, basic maintenance activities they have to do. Next is scheduled maintenance. So we have planned maintenance. Likewise, scheduled maintenance is also very, very essential. So we have daily maintenance, weekly maintenance, monthly maintenance, annual maintenance. Likewise, along with the planned maintenance, this preventive maintenance, we have to do scheduled maintenance also as a part of it. Because it depends on the type of a product. Say for this bicycles, we try to clean sometimes every day or once in a week, likewise. Then we have to apply the proper oil and all, maybe once in a month, likewise we do. Similarly, you take the case of two-wheeler. Daily, we may try to clean. And weekly, once we may try to check the air pressure. And maybe like once in 3 months or once in 6 months, depending on the kilometers we have traveled, then we used to check the oil level and other aspects we need to check. Likewise, there are some daily maintenance activities we need to do, monthly maintenance, annual maintenance, and so on. That is equally applicable for the machineries and equipment. Next comes skills improvement. So here both operators, operational skills and maintenance skills, both need to be taken care as a part of it. So that we need to provide both technical training and the communication based training as well. Next comes equipment management. That means we need to plan for spare parts, because spare parts are very critical. There may be some critical elements for which we need to maintain spare parts. So we have to plan. And also the history cards of machineries and equipment. There will be history card which will indicate what kind of major problems have happened, what kind of maintenance activities are being done. Likewise, the history cards are also available as a part of it. So that maintaining history cards and updating history cards and maintaining the spare parts is also very, very essential. So these are all the conditions applicable for TPM success. If you see here from this illustration, as a result of training the workforce on TPM, downtime is getting reduced as a part of it. So we have to train properly as a part. Okay, so now I would like to provide some practical perspectives for this 8 pillars. Say, for example, autonomous maintenance. We have to involve the operators on all basic maintenance tasks. And quality maintenance. So we need to focus on certain improvement projects to deal with the quality issues. I think someone
Participants,
have
please mute. All
unmuted.
of you, please mute. So,
Okay, on quality maintenance, some quality improvement projects have to be prioritized and we need to address the quality aspect. So in the TPM in office, the administrative activities with regard to TPM, we need to take care. Then safety, health and environmental management, we need to take care of the safety related risk and the work environment have to be enhanced. Likewise, we need to go ahead with the practical perspectives with regard to the 8 pillars. Fine. Okay, so now having completed the TPM, now we will move ahead with the value stream mapping. Okay, before we move ahead with value stream mapping, are there any clarifications in TPM, participants? Are there any queries with regard to TPM?
any questions? I think Vinod, one chat box, Mr. I think one question the posted regarding the 5 years.
Okay, sir, please read me, sir.
How far 5 years is realized in Indian industry? Means how to what extent?
Sir, 5S is one of the primary tool of lean
answered
manufacturing.
this question by citing example of TVS.
Okay, sir. Okay, sir. Thank you.
Yeah, but anyway, I would like to add a point also, sir. Because if you see,
please permit me to add one thing.
Yeah, please go ahead.
I visited Tata Motors.
Okay.
In fact, I visit every year Tata Motors to update my own knowledge as a management faculty.
Okay.
They say that implementation of 5S is not at all possible 100% in Indian circumstances. There may be claims that we have achieved 5S.
Yeah.
But actually, it's not the same.
Yeah. Yes, sir. I agree with your point from a practical perspective. But if you see, even not by the term lean manufacturing, without implementing TPM also, that 5S is a kind of management concept which had been implemented, not by the term 5S also, but this organized way of doing activities had been existing for a long time in the industries. After implementing lean manufacturing, the term 5S had been brought into picture and the activities are being done. But to the best of my knowledge, I feel that the industries have implemented 5S by and large to a larger extent, because if you see, many of the activities with regard to 5S had been done and some kind of cultural transformation had taken place. I will cite an example here. When I visited industries, automotive component industries, the operators, once they enter their shift, they go to their respective machineries and equipment. They see whether it is being clean or not. Otherwise, they clean the machineries and equipment. And they try to ensure that whatever needed with regard to processing, it's being kept adjacent to their machineries and equipment. Say the concept of shadow boards are there for maintaining the tools. Whatever instructions are available, it is available closer. And similarly, when they leave the shop floor also, they feel it is a responsibility. They keep the conditions of machineries and equipment very clean, because they know the next operator, the operator pertaining to the next shift has to do. This is nothing but a kind of a cultural transformation had taken place with regard to 5S implementation. Many such examples are there which can reveal that the 5S have been implemented to a larger extent in the industries, because the cultural transformation had taken place. Even I visited small scale industries. There also they try to follow this kind of a culture. May not be by the term 5S, but this organized working culture is in place. That's the point I would like to mention. Fine, sir?
Yeah. Thank you, sir. Like even we get to see a local taxi wala or an auto driver.
Yeah.
He also tries to maintain 5S because that personally belongs to him.
But,
that Tata Motors were saying ownership of equipment and process should get transformed to the employee. That he should develop that sense. So what the cultural transformation you are talking about, like we may throw a wrapper of a chocolate or a biscuit on road. We carry that same habit to our home also and to our workplace also. That becomes sometimes a problem for implementation. So that your words are excellent. Cultural transformation has to take place.
Yes, sir. Yes, sir. Not by the term 5S, sir, but this kind of an organized culture, cultural transformation is taking place. And if you see, sir, in some of the industries which I have done projects, joint projects, if you could see interact with the workforce, they say they have been trained in such a way that they develop ownership. They, even when we interact, they don't say it's a grinding machine tool, something like this. They say it's the machine tool which I am handling. It's my machine tool. Likewise, they are using that phrases through which we can understand the kind of belongingness of the workforce with pertaining to that particular machineries and equipments.
Yes, yes, yes. Excellent, excellent.
Fine, sir. Okay. So let me proceed further with the third primary tool, value stream mapping. So here it's a modified form of process map. So basically, process map is nothing but which shows the sequence of a process as per the product manufacturer that had been existing prior to this lean manufacturing. But after the invent of lean manufacturing, the process mapping had been modified as value stream mapping. So this value stream mapping is nothing but a tool. It's a visual tool which can indicate all actions needed for product manufacture from the receipt of material till the product is being delivered to the customer. As a part of the elements also, we discussed about the terms value stream and value flow. Value stream is nothing but the sequence of activities which is happening. Every stage, we are able to ensure that the cost is incurred, in turn value is being added as a part of it. And this value stream map will help us to understand the value flow. And it will help us to identify which activities are adding value and which are not adding value from customer's perspective. Okay. So this is nothing but a illustrative example which I have taken from a textbook-based example, which shows this value stream map. In value stream map, there are two maps we'll be creating. One is called the current state map, which shows how presently the scenario is. The next one is nothing but future state map, which shows how it should be in the future. There are two types of maps we'll be developing. So let us spend some time and try to understand how a value stream map has to be created. If you see a value stream map, it will have three segments. The one on the top is called a SIPOC cycle, which is called supplier input process output customer. That's nothing but we receive the raw material from the supplier. Then it forms the input. We have a sequence of process and we have output which is being delivered to the customer. This SIPOC cycle will be regulated by production control division. So the production control division is receiving order from the customer and they are instructing the supplier to supply the raw material because the supplier has to supply the raw material right time. Otherwise, the product manufacture cannot happen. We have a sequence of process starting from inspection of casting, drilling the location holes, drilling the fixing holes, boring the main bearing diameter, fixing the bearing and shaft, testing, assembly and dispatch, and the product is being delivered to the customer. So this is nothing but the first part of the value stream map, which is called SIPOC cycle. And if you see the second segment, we have all process attributes. Every process we will have, what is the cycle time, what is the changeover time, what is the available time, uptime, how many number of operators are there, and so on. All process related attributes we'll have in a typical box and we will represent. And the below one, we will have a kind of a timeline. Let me show another illustration where, just for example, for explanation purpose, it is being made as per all the conventions. As I mentioned on the top, we are having the SIPOC cycle, and the second list is nothing but the process attribute box, and the third one is called the timeline. So the timeline, there will be a upper segment and the lower segment. The lower segment will correspond to the cycle time and the top segment will correspond to inventory being converted to time scale. So here, these are the three parts of a value stream map. One on the top, SIPOC cycle, second process attributes, third one is nothing but the timeline as a part. So here, they need to have an understanding on the basic terminologies. Okay, so cycle time is nothing but the time elapsed, the elapsed time between one part coming off the process and the next part entering the process. Changeover time is nothing but the time required for changing from one product variant to another product variant. So the cycle time has to be measured through a stopwatch study. We will try to measure the cycle time. And the changeover time also we have to measure. And this available time is nothing but we will calculate from the shift time. The shift is being designed for normally for 8.5 hours or 8 hours. From that, we try to subtract the allowances, maybe the lunch break, the tea break, the preparatory activities and all we subtract and we calculate available time. Then uptime is nothing but it is the ratio of we try to subtract the changeover time from available time. We take the ratio to available time. We calculate uptime. It's a part of it. And for every process, we calculate, we measure the cycle time, we measure the changeover time, and we calculate the available time, uptime, a number of operators will be represented, and the process name, and so on as a part of it. So let me go to the textbook-based example. So if you see here, in this particular value stream map, the customer requirement is 4,000 per month. The organization is producing 1,000, that is delivering 1,000 per week. And daily production is nothing but 200 numbers. And they have raw material inventory of 1,000 numbers and work in process around 3,000 numbers and finished goods inventory 400 numbers. Total inventory put together is nothing but 4,400 numbers. So here, we need to analyze the inventory. It is nothing but the total inventory is 4,400 numbers, and that we are converting to the time scale. So it's nothing but how to convert inventory to time scale. We have to take that total inventory. We have to take the ratio to the daily production. Daily production per day is nothing but 200 components per day. When we take the ratio to that, we are getting 22 days. So the inventory of 22 days is nothing but very big. So why we are converting inventory to time scale is nothing but it will help us to understand the magnitude of inventory, and it will help us to calculate the lead time more effectively as a part of it. So now let us analyze this value stream. So once we got a current state value stream map, we need to identify which activities are adding value and which are not adding value. We need to analyze as a part of it. Okay. So here, if you see in this sequence of activities, we have the first process, inspection of castings. Is it a value adding activity? Is it a value adding activity? Whether inspection is it a value adding activity? It's not so, because it's nothing
but a business adding, value adding.
Yes, madam. Yes, madam. So it is necessary but non-value adding activity. So that has to be removed. And similarly, if you see, we have to explore whether there is any possibility to combine the process. Say, for example, we are having the second process, drilling location holes, third one drilling, fixing holes, then boring the main bearing diameter. All those three processes can be combined into a single process. The drilling and boring operations can be combined into a single process. Say, for example, we can go for a kind of a CNC driven multi-process machine tool so that we can try to combine all these three processes into a single process. Next, if you see the fifth and sixth one, fixing the bearing and shaft and testing, assembly and dispatch, their assembly come testing, we can combine those two. So the first one we have eliminated, and second, third, and fourth can be combined into a single process. Fifth and sixth can be combined into a single process. So from sixth process, we could see it had been converted to two processes in the future state as a part of it. Next, we have to see, understand the customer requirement. It is nothing but the customer requirement is nothing but 4,000 per month, and we are the organization is delivering 1,000 per week. Even sometimes customer may need daily delivery to their end, but it cannot be possible. We have to consider the practical constraints, the logistics and other constraints also we need to consider. Okay, so that's why we need to have a very clear understanding on customer requirement in terms of delivery schedule. And second thing, the customer needs or the customer attributes we have to understand very clearly as a part of it, because that is being converted to design requirements and process requirements. When we clearly understand this customer requirements, it will be more effective as a part. Third one, the supplier capabilities and constraints. Supplier constraints also we need to understand. Here, if you see, the raw material supplier is supplying 1,000 numbers. So that they might have discussed and they might have arrived at the economical quantity to be supplied because the raw material supplier may be located at a farther distance. Considering those aspects, the economical quantity, they worked out to be 1,000 castings per week. Next one, current inventory and WAP. That is what we have calculated. Say we have found the total inventory. We have taken the ratio to production per day and we got the total inventory. Inventory we converted to time scale. I mentioned the advantage because we'll be able to understand the magnitude of inventory and it will help us to calculate lead time. The inventory definitely we have to convert to time units. Next parameter is called computing takt time. Takt time is nothing but the ratio, the time needed to complete an activity in order to meet the customer demand. Say for example, takt time, how we calculate, it is the ratio of available time to customer demand. So here the available time is nothing but when we take the 8.5 hour shift, that is 5-10 minutes, when we subtract the standard allowances of 60 minutes, we'll be getting 450 minutes as the available time. So available time is 450 minutes and customer demand is 200 per day. So when you take the ratio, it will be nothing but 2.25 minutes. So we have to analyze whether the individual cycle time of the process are in line with takt time or not. If you see the process 1 and if you see process 3, process 4, process 5, process 6, all their cycle times are more than that of the takt time. But it has to be less than, it has to be within takt time. Then only we'll be able to comply with the lead time. That's why we compute takt time and analyze what prevents us in complying with the takt time. We have to explore, we have to go for balancing the line and other concepts also. And also we have to ensure there is continuous flow and we have to make as a single piece flow. That means the components are moving one by one without any delay, without any interruption. It is happening as a part of it. Next, we have to go for balancing the line. So line balancing is very, very essential, which will help us to ensure that the individual cycle times of the process are closer to each other so that there is no accumulation of inventory. The process will be more streamlined. Then we need to make a future state map. If you see in the future state map, from earlier we had 6 processes, we have converted to 2 processes. The drilling and boring are being converted to a single process and assembly and test are being converted to a single process. From a push system, we have converted to a pull system. Thereby, we could reduce the cycle time of the process. It had been made like 2.25 minutes, like that of the takt time. And if you see further modifications, the work in process inventory is being made 0. Earlier, we had 3,000 numbers. So here we are adopting the pull system, trying to make the process more synchronized. The WAP is being made 0. Thereby, the total inventory got reduced to 1,400 numbers. So earlier from 22 days of inventory, we could now reduce to 7 days as a part of it. And if you see the number of operators, earlier for every process, we had 1 operator. 6 operators we had. But here, how many operators are needed in this future scenario? How many operators are needed for this scenario? Participants?
Participants, please interact with the speaker.
Okay, let me tell you here, right? Earlier we had 6 operators. Now we could see a single operator is sufficient. Even 2 operators are not needed because it's a CNC driven machine tool, drilling and boring. Once the operator loads the component, the operator will be free. The operator can take care of fixing at assembly and testing. So once the operation gets over, then the operator will go to the first machine tool. From 6 operators, it got reduced to a single operator. From 6 processes, it got reduced to 2 processes. Inventory from the 3,000 numbers of WAP got reduced. From 22 days, it got reduced to 7 days. Then quality improvement, then free space also will be created. The space optimization, other things also we can attain. This is the significance of value stream mapping as a part of it. So it will help us to analyze the process more effectively as a part of implementation. Okay, so you could see operations from 6 to 2, then operators from 6 to 1, inventory from 22 days to 7 days. And the space, it got optimized by 60%, lead time reduction also will happen, and quality improvement had happened, and supplier quality also got improved. So here, very important thing is nothing but in value stream mapping, we have to be very clear with the data parameters. So here, some of the data parameters are nothing but they are observation-based data parameters. Say, for example, shift time. It's an observation data. Number of operators. What are all the process? They are nothing but observation-based data. Then we have some measurement parameters. Say, cycle time we have to measure. Changeover time we have to measure. They are all measurement parameters. And inventory we have to measure between the process. Next, they are computation-based parameters are there. Say, for example, we have the available time, we have to compute, uptime we have to compute, takt time we need to compute, lead time we need to compute. Likewise, we'll be able to do it. So if you see in the value stream map, once we sum up all individual process cycle times and the changeover time, we'll be able to get the total lead time as a part of it. Okay, so that also we can analyze and we can do. So there are observation-based parameters, measurement-based parameters, and computation-based parameters. So there are two types of mapping. One is current state and future state mapping. And I have shown what all the perspectives we need to analyze. Once we draw a current state map, we have to analyze from all these perspectives, and then we have to arrive at the future state map. The future state map is a prediction as a part of it. So here, this is nothing but a textbook-based illustration I have shown. But I have few case studies also, maybe 2 case studies I have, which I can do in my tomorrow's lecture, because tomorrow morning session I'm having a lecture, and with the permission of organizers, these 2 case studies I'll be able to include in my tomorrow's presentation, because we have another 5 minutes to we have to devote for discussion, and those 2 case studies I'll be continuing in my tomorrow's presentation also. Okay, now we have 5 minutes left out, so any questions from the participants, I'll be happy to answer. This 5 minutes we'll devote for interaction.
Yeah, dear participants, you can unmute yourself, ask any questions.
Vinod?
Yeah.
Karthikeyan here.
Yes, sir.
It's that maybe this type of mapping will serve, definitely it will reduces the inventory cost and also increasing the productivity, no?
Yes, sir, definitely, sir. Yes, sir.
Okay. So any case studies related to our day-to-day life, maybe student life, maybe mapping this type of activities?
Yes, sir, definitely, sir. Yeah, it's a very real life, it's a tool which can be used for any real life applications, sir. Yeah.
Because students 4 years of engineering education, they have to map their aim and find out how they're traveling during the course period, maybe what is the outcome.
Yes,
so
sir.
That may be mapped, no?
Definitely, sir. Yes, sir.
Okay. Participants, any query?
Any queries from participants?
Okay, participants, please, all of you start your video. Let us take one group photo, and with the feedback, we'll close the session, and after we'll go for next session at 11:15.
Okay, sir, just 2 minutes. Let me summarize, sir. Okay.
Yes, sir, sure. No. Okay,
yes.
okay.
Just 2 minutes, sir, then we can proceed. And today we started with the discussion on the fundamentals of lean manufacturing, and we started with the concepts wherein we studied about the definitions, elements of lean manufacturing, 5 elements, and we went ahead with the discussion on 3 primary tools, 5S, TPM, and value stream mapping. Then we discussed about the practical perspectives also. So I have 2 more case studies on value stream mapping to be shown. Let me show in tomorrow's presentation, and we will continue. Okay, so yes, thank you all. So it's fine, sir, from my side.
Okay. So I taken the screenshot. Okay. Then I request our colleague Sadi sir to summarize the session.
Yeah, thank you, sir. I thank all the participants and also the speaker of the session, Dr. S. Vinod, for his wonderful speech on today's topic. And he has covered some of the basics on this lean manufacturing. Started with elements of lean manufacturing under the different headings of value streams and what is 5S and how Japanese terms are converted into lean manufacturing terms and basic conditions of applicability of TPM success for the TPM success in value stream mapping, the current state of mapping, analyzing the mapping, and the future state of mapping. So those are discussed in this session. Requested all the participants to mute. It was a great session, sir. I thank on behalf of Rajarashri College of Engineering and Department of Mechanical Engineering. I thank the speaker of the session, Dr. E.S. Vinod, Associate Professor in Production Engineering Department, NIT Tiruchirappalli. Thank you for your participation, sir.
Yeah, thank you, sir. I would like to thank Professor Karthikeyan and other coordinators, and also I thank all participants. Okay, for the patient listening. Okay, so let's.
Okay, thank you, Vinod. Let us meet again.
Thank you all. Have a fine day. Okay.
Okay, thank you.
Thank you, sir.
Thank you, sir. Thank you so much, sir.
Okay.
Okay, madam. Thank you.
Madam, all of you participants, I shared the link to feedback link and on facility feedback link today morning first session arguments in the canvas. And also I put it.
Karthikeyan, sir, I'm leaving the meeting, sir. Okay. Thank you, sir.
Topic of Smart Manufacturing Industry 4.0, Dr. Raju B.S., Professor and Special Officer Evaluation, Reva University, Bangalore. So all of you please join at 11:15. Thank you.